Today we're doing lesson 2.8, equivalent fractions on a number line. So we've done the math warm-up. We decided that a good estimate was about right was 1/12. And then one that was too small was 1/20th, and one that was too big was 1/2. Now we are on to page 73. Everybody on 73? Okay. Don't want to you to be distracted. Andre used number lines to find fractions that are equivalent to 1/5. He drew this number line. So he drew this one right here. Then he drew 3 more lines and wrote a fraction for the point on each line. Do you see on those number lines what is all lined up? You guys see the zeros all the way down?
Yes.
And you see the ones all the way down? And you see the points all the way down in the same spot, right? Okay, so those are all lined up. It says, how did Andre use the number lines to find fractions equivalent to 1/5? So the first thing he did, as you can see, is he made a number line that had 5 sections. See that? I want your eyes up here, please. I am looking for students who are going to sign the woe board. I'm fine if all of you sign the woe board at the end of this, but if I look over and you're not focused, then it's not happening. Okay? All right. So he made a number line that has 5 sections, right? And then he drew a point at 1/5 at the first section. How did he change this number line this time around? What did he do different? Fisher. How is this number line different than this one?
It has 2 halves
Huh?
instead of 1/5.
Well, what did he do? So he drew this one first, Fisher. Then he drew the exact same thing right here. But how did he change it?
He chopped it up by 5.
What do you think, Evan? What did he do? So he drew this one first, and then he drew the exact same thing here. But then he changed it a little bit.
Wait, he made it 2/10.
How did he make it 2/10 though?
He
There's only
switched.
5 sections.
Well,
How do you make 1/5 into 2/10?
because they're equal.
They are equal. What did he have to do though? Athena, what do you think?
He split
He's
the fist in the middle.
He split them in the middle, right? And then that went from having 5 sections into how many?
10.
10. All right, does that make sense?
Yes.
See where I was going? How did he change this number line down here? What did he do? Jackson?
He used the exact same number line with the 2s, just he added a line in between all of them.
He added a line in between. Did he add just one line?
He added 2.
He added 2 from each one, right? So he made that one section into how many sections?
3.
3. Hey, I have a question for you. What do you multiply 5 times to get 15? 3. Oh. Now, on this next one, our denominator's 20. How many sections did he split? How many sections did each of the sections get split into on that number line? Todd?
3.
Look at it again. He drew 3 lines, but how many sections did that make?
4.
4. He made it 4. Now, What do you multiply 5 times to get 20? 4. 4, right? You see it? Okay. Are you starting to see this connection here a little bit?
I
Okay.
get it.
All right, okay. So, this is what he did. He made his number line that had 5 sections. And then he found 1/5, right? So this is 0, 1, 2, and this is 1 whole. And then he made another number line that was the exact same size. So he went boom, 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 boom. 1 here, 0 here. But he said this time, I'm going to split each section into 2. That's like doubling it, right? And when we do that, we go from 5 sections to 10, and we would go 1, 2 jumps, okay? Then, on the next one, he started with the same size number line. Okay, are you seeing the pattern here?
Yeah.
And he identified this point, and he said, this one, I want to have 15 on the bottom. That means each of the sections, to get from 5 to 15, Macy, we have to multiply by 3. So each section became 3, okay? And if you multiply 1 times 3, you get 3. So 1, 2, 3. And then he did the same thing with 20. You guys seeing how that works? Fisher, you got something?
I noticed that it goes 1/5, 2/10, 3, 15, 3, 4, 20, and it goes how much it takes 5 to get to that number.
You're
It
exact.
goes 1, 2, 3, 4, and it takes 2 5s to get 10, and 3 5s to get 15, and 4 5s to get 20.
Nice connection, Fisher. I love it. That's exactly right. So it's a very, very cool pattern. There's Fisher. Okay, it's a very cool pattern. Watch this. 1/5, 2/10, 3 15ths, 4 20ths. What are the top numbers going up by each time? What are the top numbers increasing by each time? Colton?
1 on the numerator row is going up by 1. On the denominator row is going up by 5.
Yes. Yes. All right. So this is why I love fractions, because they're all about patterns. Okay. And what Fisher pointed out is the patterns go top to bottom too. 1 times 5, 5. 2 times 5, 10. 3 times 5, 15. 4 times 5, 20. Right? This is why I like fractions. Okay. So it says, how can number lines be used to show whether the following fractions are equivalent? Okay. So we've got a number line that says, they want to know how number lines can be used to show 8/10 and 4/5. I'm going to use my fancy number line up here because it's beautiful. Admit it. Okay, so if I find 4/5, 1/5, 2/5, 3/5, 4/5 is right here, right? And what do I need to do to make this number line show 10 sections instead of just 5? Evan?
Add 2 more. Wait, no.
Each section gets split into how many?
5. No. 5ths.
It's already in fifths. So here's how I'm gonna word it. What do you multiply 5 times to get 10?
2.
That means each section now becomes 2. And in order to split, yes, it's hard to put it into words sometimes. And if each section becomes 2, then I need to just draw one line all the way down. Split them all in half, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8 tenths. Are 4/5 and 8/10 equivalent?
Yes.
Yes. Okay, so write this down real quick. You can make a number line with 5 parts and find 4/5. Then split each part. There won't be too much writing today. Split each part into 2. So you have 10 parts. Last, find 8/10, which we did, and we found that they were at the exact same spot. While you're copying that down, I'm gonna start making the next number line. All right. If you didn't quite finish getting that copied down, it's okay. I'll put it up at the end.
I don't have any more room.
The arrow kicked off of this there. Okay. I know that you can you can write down here. Whoops. You can write down here too if you need to. Okay. So now we're going to see if 14/20 and 4/5 are equivalent. I've made a number line that shows 4/5, right? It's got 1, 2, 3, 4, 5 sections, and I put a point at 4/5. Everybody got that? Okay. Now, what do I have to multiply 5 times to get 20? Oh, 5 times blank equals 20. 4. So that means every one of these sections needs to become 4. When we split something into 4, how many lines do I need to draw? Zerelda? You start to say it.
3.
It's 3 because we always do one less line than what we need. Okay? If we need 4 parts, we do 3 lines because watch. A line in the middle splits it into 2. One line makes 2. If I split both of those, now I have 1, 2, 3, 4 sections, but I just drew 3 lines. If I do something to this section of the number line, do I have to do it all the way across?
Yes.
Absolutely. So I'm going to do that now. And once I get this all finished, then there's going to be how many total sections?
20.
20, because I made each one into 4. And 5 sections times 4
Equals 1.
exactly. So now let's count and see. Let's find 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14/20 is here. Are they equivalent? No. Because they're at different points, right? So, not equivalent because they are at different points. last one on this page says find 3 fractions that are equivalent to 6/5. Explain or show how Andre's number lines can help. We're gonna show, okay? So, we're gonna go slide back up here to the number lines that Andre drew. The first fraction that we need to find is 6/5. What is the highest that this number line goes to?
5/5.
5/5. So what do we have to do, Avis, to find 6/5?
We have to extend the number line.
Bingo. We have to extend the number line. We got to make it longer. Just by one little section, though. We have to add on to this to about right there. Okay? So I'm going to do this in a different color so it stands out a little bit better for you guys. So you can see what I'm actually drawing. Okay? So I'm going to take this. You need to do this as well, yes. So do what I do in blue on your number lines, okay? Mine's a little short. Okay, I'm gonna do that here. I'm gonna do the same thing all the way down. So I need to extend all of these number lines and make a tick mark at the end of them. Yep. That one was up Okay. Now I've extended all 4 of my number lines. And your space to the end should be about the same width as this space right here. And you need to make sure that the points line up as perfectly as possible. Because 6/5 is going to be right here, isn't it? We know 1 whole is 5/5. So if we jump 1 more, this would be 6/5. Okay? So write that down. 6/5 on the top one. Now, you remember what he did over here in this section? You okay? Okay, he split them all in half, didn't he? So he had a number line that looked like this, and then he went boom, 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 boom. And so we've got to do that here. Boom. Right in the middle. All of them? Nope, just that one. Okay? So, our point is right here. And this number line has 10 sections between 0 and 1 whole. So 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, 11/10, 12/10. So our point is at 12/10, and that makes sense. Keep up with me, Ben. That makes sense because what's 6 doubled?
12.
What's 5 doubled?
10.
Okay, so far so good.
I know this.
On this one, between 0 and 1 whole, how many lines did he add?
He added 2.
He added 2. So I'm gonna add 2 as well. You with me?
Yep.
Okay. And this denominator is 15. So what would 1 whole be? If the denominator 15 fifteenths, right? Okay, because when you have 1 whole, it's the same number on top and bottom. We know the denominator is 15, so 1 whole would be 15 fifteenths. 16 fifteenths, 17 fifteenths.
18 15.
There you go. 18 fifteenths is right here. 18 fifteenths. Do you see how we got that, Todd? We could have gone all the way from back to here and counted, but it's easier and quicker if we start with one whole and say, well, my denominator's 15, so I know this is 15 out of 15. This would be 16 out of 15, 17 out of 15, 18 out of 15. And then, on the last one, how many lines did he add between 0 and our point? 3. So we need to do the same thing here. So I'm going to go 1 in the middle and then split each one. That is not a good job. I didn't do a good job. Okay. 1 in the middle and then boom, boom. Okay. So if my denominator's 20, what would this point or one whole be?
20 20th.
20 20ths. And so this would be 21 20ths, 22 20ths, 23 20ths, 24 20ths. Very good, guys. We just use those number lines to find 3 fractions that are equivalent to 6/5. And I want to point something out to you over here. And that's all the writing we have to do on this page. Yes.
I noticed that on the bottom row, the same numbers that are on the dotted, the black dotted fraction, the denominator's the same on every one of them.
That's exactly
And on the
right.
top, it's going by 6s instead of 1s.
Now you were onto something here. So 5 and 5, 10 and 10, 15 and 15, 20 and 20, right? And then they're counting by 6s.
On the numerators.
Colton, you go. Yes. 6 times 1, 6. 6 times 2, 12. 6 times 3, 18. 6 times 4, 24. Nice, Colton. That is what I'm talking about. That is what I'm talking about. Okay. What do you see, Jackson?
That the denominators are all the same, but then if you add the numerator and the denominator, you'll get the final number in the numerator that we wrote.
So are you saying if you add 1/5 plus 5/5, you get that?
No, I'm saying if you add like 1 plus 5, because it's 1/5.
Uh-huh.
So if you add 1 plus 5, you'll get 6 as your numerator.
Oh, I see what you're saying. That is crazy. I didn't even pick up on that. Look at this, guys. He's saying, what's 1 plus 5?
6.
Boom. What's 2 plus 10?
12.
Boom.
Oh,
What's 15 plus 3? 18. What's 20 plus 4?
24.
So cool. Nice catch there, Jackson. I didn't even see that. Very good.
Yeah, you could just
You
see
guys
that-
are seeing the patterns now. It's coming alive. You're seeing them. Yes, Todd. Okay, it did. And you know what? That's exactly the process that
What
you.
I was gonna say that it goes like 12 plus 12 would be 18, but no, it isn't.
So it doesn't double there, but let me show you what it does do. Okay, so we have 6/5, 12 tenths, and then we have 18 fifteenths, and then we have 24 twentieths. Now watch this. What is, and we already know that 6 times 2 is 12, 5 times 2 is 10, right? Watch this. If we start with 6/5 and we multiply by 3, we get 18 fifteenths. If we do 6/5 multiplied by 4/4, we get 24 twentieths. This right here is another way to see if fractions are equivalent. If you do it to the bottom, and you do it to do the same exact thing to the top, as in multiply by 2 and 2, then those fractions are equivalent. All right, we need to move on real quick. We got one more page to do. Okay, here we go. Can it be done? Priya wants to find fractions that are equivalent to 2/3. Other than 4/6, she wonders if she can find equivalent fractions with denominators of 9, 10, and 12. So here's what she does. She makes a number line that shows 3 sections, okay? And then she finds 2/3. With me so far? So she's wondering, can there be equivalent fractions to 2/3 that has a 9 on the bottom, a 10 on the bottom, or a 12 on the bottom? I'm gonna go through this one kind of fast so we can get finished up, okay? All right. So here's what she does. On the first one, she knows that to get from 3 to 9, you multiply by 3. So she splits each of these sections into 3 sections. And once she does that, she has 9 sections. Okay, so let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so 1, 2, 3, 4, 5, 6, 9. Her first fraction that's equivalent to 2/3 is 6/9. Okay? And that makes sense because what do you multiply 3 times to get 9?
6.
No, 3.
Wait, 3 times 3.
And what do you, and then if we do it to the top, what's 2 times 3?
6.
6. That's what we found. 6/9. Okay. What can you multiply 3 times to get 10?
3 times.
You can't because
There's nothing, right? 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So 10 won't work. She cannot make a fraction that is equivalent to 2/3 that has a 10 on the bottom. So 10 is not a multiple of 3. And that is why she can't make a fraction equivalent to 2/3 that has a 10 on the bottom. Okay? Because there's nothing we can multiply 3 times to get 10. Won't work.
It'll just skip to 12.
Exactly. So what do you multiply 3 times to get 12?
To get 12,
4, yes. So on this next one, I'm going to split each section into 4 by adding 3 lines. 1 there, 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 and 1 there. Now, I should have 12 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Now, we need to figure out what goes at this point right here. 1, 2, 3, 4, 5, 6, 7, 8. 8 12ths. So that is the third fraction that's equivalent. And let's see if that makes sense. Jackson just told us that we multiply 3 times 4 to get 12. If we do it to the bottom, what is 2 times 4? 8. 8 12ths. Boom. Okay. Last question. Represent 1/10 on a number line. That's the first direction. So I'm going to split it in half and then add 4 more lines to each side. Split it in half. hard to do. 1/10. Then find two fractions equivalent to 1/10. We're just gonna find one. We're just going to, I'm gonna go ahead and split these all in half, and that will make how many sections? 20. And 2/20 would be equivalent to 1/10, right? What do you need, bud?
I noticed that if you just erased 1/10, if you erased 10, it would be going by threes. 3, 6, 9, 12.
You're getting it, okay? See, that's what's so cool about fractions, Colton. I'm proud of you, buddy. Nice job. Okay. Hey. They want us to now make a number line that's this big that has 100 sections.
Oh, wait, we don't have to do that.
We don't have to do that. Why, Evan? What'd you say? You're on the right
Wait,
track.
we can do it by multiples of 100.
Factors
Yeah,
of 100. Oh, the numbers that 100 is a multiple of. What can you count by?
Oh, tens.
Tens. Jackson and Fisher were just like, column it. And Samantha's like, I knew it. And Evan's like, 10. How many times has that happened today? You've got an answer and somebody blurts it out.
Yeah.
And you're like, no. It's all right.
he
It's
was
all right.
so sad.
You guys are doing so good. I'm super proud of you. Okay, so you're too excited. You can't contain it. You can, absolutely. We're going to count by tens because I'm going to show you, because we can use the same number line that we did up here. So split it in half. 1 second, Geralda. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, Macy, are y'all good? What do you think? I'm trying to get this finished so we can wrap it
Does
up.
your colors change colors or?
I picked a different color.
Oh,
Okay.
I
All right.
thought it was changing colors.
So Evan said count by 10. Let's do that. If this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 in the whole thing. So one whole would be 100 hundredths. And what would be right here? What fraction would go right there?
Oh, 10.
Fisher? Yes, just say it without the 1.
1.
So it's just 10 hundredths. But yes, you got it, Fisher. 10 hundredths. Now, last thing that I think is super cool, when you're working with fractions and you're working with, watch this, 1/10, we just said is equal to 10 hundredths. This is cool. You know my rule, Macy, if you do it to the top, do it to the bottom. If you do it to the bottom, okay, watch. That includes this.
Just add a 0. Just add a 0 on both of them.
And 10.
You can cross out zeros too,
Add a
or
0.
add zeros,
Add a 0 on the 1, add a 0 on the 10.
okay? If we cross out zeros, it's dividing both by 10. If we add zeros, it's multiplying both by 10. All right, we've got a quiz to do, so let me stop this.